4.2, polynomial functions and their graphs. 7.2. We're going to graph p of x equals x cubed plus 3x squared minus x minus 3. Actually, I'm not going to do that. So, get out your calculator. Get out your calculator. We're going to type in the function into f of x. Remember, p of x, h of x, g of x, whatever, is just the name of the function. X cubed plus 3x squared minus x minus 3. When you get it typed in, type zoom 6. When I hit zoom 6, all that does is it gets everyone on the same exact page. There's my graph. I'll take this graph. Okay, right here. There's my graph. What do you notice about it?
One valley and one peak.
One valley. Right. But if I look from here to here, it goes up. From here to here, it goes down, and then it goes up after. What's this point right here called? That is a maximum. This is a minimum. It is a local maximum, local minimum. Why are they locals? This one doesn't have a maximum or a minimum, because the lowest it goes is infinity. The highest it goes is positive infinity. But at one point, this is the local max. At one point, this is the local min. All right, what we're going to do is we're going to say when it's increasing, when it's decreasing. All right. How do I find this max point?
Zoom trace. Trace. Zoom.
I don't want to trace. I don't want to trace this. I want to know exactly what that minimum or that maximum point is. Second, trace. I want to know the maximum. So I have 4. Now what I need is a left bound. I need somewhere over here. Just, okay, not 3. Not 3. Not 3. Negative 3. I can just, instead of using the arrows, I can type negative 3. Press enter. Now I need one over here. I can use 0. That's fine.
Negative.
0.
What did we press?
Press enter. We just picked it. Negative. The maximum is at. The maximum is at negative 2.15, 3.08. That's my maximum. This minimum. The minimum, second, trace, minimum. Here's the minimum here. Give me a point before it. 0. It looks too close to me. Negative 2, that's fine. Give me a number past this. 5. Doesn't matter how far away. I just don't want things that are super, super close because I might miss it. My minimum's at. So I'm going to use a minimum, 0.15, and negative 3.08. There's my max and there's my minimum. Yep. What do you mean? That's just a coincidence that the numbers are similar. Now we're going to write the intervals. I'm going up, so I'm increasing, and I'm decreasing, and then I'm increasing again. We're just talking about the x values. The graph starts doing this. Where do I start down here? How far do I go? Forever. So it's increasing from negative infinity to, when does it stop increasing? Infinity symbol. Sideways 8. What does it? When does it stop increasing? Negative 2.15. Because once it hits this point right here, what happens? It starts to decrease. So it starts to decrease at negative 2.15. When does it stop decreasing? Zero. Whoops. 0.15. Now, what happens after this point? Goes up. So it starts at 0.15 until positive infinity. Yes. Different graphs. Every graph will be different.
Why is the negative 2.15 in the y spot?
These aren't xy values. These are intervals.
Okay.
These aren't xy values. They're the intervals in which it's increasing, decreasing.
Well, I cheated and looked in the book. I saw the graph. So what happens when it's like a double? Oh my God, what is that?
Any polynomial can be written in standard form as p of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 a sub 1 to the x plus a sub 0. It looks confusing. This is the highest degree right here, right? And then it goes down each time until you get to a 1, and the next one is a 0.
Oh my gosh, that's true. A to the sub n, x to the n plus
The leading coefficient, a sub n x to the nth, will always tell us the end behavior for any polynomial. The highest degree will tell me what the graph will look like.
You didn't ask my question.
What?
What is the x to the n? Like, what is that?
Give me a number. So 5, this one's 5, 4, 3, 2, 1, nothing. Those 10, x to the n is, that's whatever degree u is. If I have a polynomial that n is even, I don't know, just, no, there's no reason why. Yeah, that's 28, that's 25. If a is greater than 0 and n is even, what this means, this term right here, give me a number that is greater than 0. 2. Give me a variable that is even, or sorry, a number that is even. Let's use the smallest one, 2. We'll do 4 next, just to show you. All right, 2x squared. Zoom 6. Doesn't affect us. Looking at my graph, to the left, how does it open? How is it pointing? Up. To the right, how is it pointing? Up. Yes, there's stuff that happens in the middle. I'll show you the 4th. Do the arrows. I'll change them to 4s just to show you. Graph. Actually, let's... What happens to the left? It's up, and to the right it's up.
So we're doing, like, we had to put the arrows, like, slanted.
Yeah, they're not straight up, they're slanted. So this rises, this rises. All right, Shonda, you said if it's negative, right? Let's throw some negatives in front. If I put a negative out front, what happens? This is now going down over here, down over here. It is falling. It's falling over here. This works for any polynomial. Yep. If I had 20x to the 1028, what is my graph going to look like? Okay, there's going to be stuff that happens in the middle. All I want to know is the end behavior. It's going to be up and up. I don't know what happens in the middle, but I know it's going to be pointed up and up. Now let's look if it's odd. 3. So something cubed looks like this. Okay, left it's going down, so it's falling. To the right it's rising. Now, what, over on the arrow? Oh, no. Because it looked like you were doing the pattern. Right. 5. I'll just use 5th. It's the same thing. Over to the left, it's going down. To the right, it's going up. If I use a number less than 0, what do you think is going to happen? This one's going to rise, and this one's going to fall. The leading coefficient tells me the end behavior. Questions? Yeah, this is just the general polynomial function.